Hey Airflow community, we've got exciting news. The annual Apache Airflow survey is live. In just 7 minutes, you can help shape the future of Airflow and grab a free Airflow 3 Fundamentals or DAG authoring certification worth $150 each. Plus, you can enter to win an exclusive workshop with Mark Lamberti. Don't miss out. The survey link is in the show notes and closes November 21st.
Hello everyone, welcome to the Data Flowcast. I'm your host, Mark Lamberti, and today I'm joined by Oscar Ligthart, lead data engineer at Vinted, and Rodrigo Loredo, lead analytics engineer. I'm super excited to have you both here for this episode. But the first question is, how you are doing today?
Great. Yeah. All is well. Excited to be on this episode. Excited to talk a bit about the work we've been doing and make it known to the world. And hopefully be in the position to answer some questions.
Yeah, no, that's gonna be amazing. I'm so happy that we are finally making this episode. So today we are talking about how Oscar and Rodrigo coordinate data workflows across multiple teams by building a code generation system that I'm super excited about. Actually, that lets users configure pipelines through YAML files, while completely abstracting away the complexity of writing Airflow DAGs, which is pretty awesome. But first thing first, I would like to start with a very brief question. Can you tell us more about who you are? What is your background and what you do at Vinted?
Yeah, of course. I can start. So as you said, I'm a lead analytics engineer. And well, I've been working in this Airflow project for a while. But before I was actually in the trenches doing the pipelines and writing the SQL code and actually being a user of the solutions that we have. So when I joined the platform team, I was team up with Oscar to try to actually do something better for the people, because we saw that different types of teams had different knowledge, and this was an opportunity to do something that actually boosted how we use Airflow at Vinted. So now I'm more on the dark side, as we said, and trying to be the voice of the analytics engineers and trying to bring the features that they use into the data platform to make that work awesome, as I want to say it. So yeah, that's me, and my experience has been in data engineering, analytics engineering, and also some data science with ML things. But a little bit of a different background. I'm now more focused on this part of infrastructure mostly.
Do you miss missing in being in the tranche?
No. Not really.
Okay. What about you, Oscar?
Yeah. It's different trenches that we're now.
Okay.
And I was actually very happy to have Rodrigo on board, having been in the trenches, understanding which parts worked and which parts didn't work very well, because you get firsthand experience and you really can use that in designing your solution. But for me personally, I have a background in AI, which is a very exciting field to be a part of, to have learned the basics in. And I transitioned into data engineering, so I really, in that sense, jumped into the trenches. Been at Vinted since the beginning in the platform team for about 1.5 years, of which I think last year has been spending on this project, which I really thoroughly enjoyed, and I think the result of it is something to be proud of, if I do say so myself.
That's awesome. Thank you both. So I guess obviously as a lead data engineer and the lead analytics engineer, you are both managing data workflows across, many different teams, analytics engineers, ML engineers, data scientists. What does that organizational landscape look like? And what challenges were you facing when teams were working independently with their own Airflow setups? Because obviously, when you have many teams like that, usually they are all working in silos. Can you tell us more about, those challenges that you faced?
Yeah, of course. So Vinted is Europe's largest secondhand marketplace, and we're active in over 20 countries, and we're at the core a data-driven company. So with millions of transactions per week, you can imagine there's quite some data flowing through these pipelines. We used to have a monolithic approach where teams would be in a single location, working on a single repository. But in order to stay ahead of the growth, we decided to decentralize these teams. The tooling we then gave them was dbt. We did pipelines with Vertex AI for any ML jobs. We had Spark jobs and containers that people could build. And with the decentralization of teams came challenges, as you said, like how do we handle dependencies? As you can imagine, when you have a monolithic repository, it's quite easy to see what's where, how to use things, how to grab things, see if they match or not. And when you start decentralizing the teams, this becomes more tricky to do. But not only that, what we also find is that when people have their own setups, is that people start designing their own solutions.
Right.
And this can be seen as an advantage because people can work in a decentralized way in a fast manner. But for a centralized platform team, this is the nightmare, so to speak.
Yeah.
In the sense that we still have to maintain this platform. And with these differing solutions coming to play, it's very difficult to have an understanding of the total landscape and also be able to maintain it, upgrade it, keep it clean, keep it scalable, you name it.
And like, so how, actually, so to avoid being in that nightmare, what did you decide to do? Like, because I mean, I already know a little bit, and actually you mentioned that at the beginning, but can you tell us more about what is the solution that you found, and what exactly, in which way it helps you to have that solution today?
Yes. So what we did, as you mentioned previously, was that we built a generator, which acts as an abstraction layer between the user and Airflow. So what is this abstraction layer? We allow users to configure through YAML what their pipeline should look like, which is then fed to a generator, which uses a predetermined amount of building blocks to create a pipeline. And what this enables us is that we nudge users to create pipelines that sort of, as little pieces in a puzzle, fit together. So instead of having isolated silos, each in a specific shape, we sort of mold it to ensure that if you're building that grand puzzle, that things fit together. So with these limited amount of building blocks, we can ensure that these dependency problems that we mentioned before can be handled, because we can make contracts on how teams provide input and output. We can make contracts on how we handle dependencies, how we ensure that whenever something upstream fails, that people are notified correctly, or that all the downstream processes wait until they're actually getting the green light from their upstream dependencies, and so on.
So this abstraction seems to be a little bit more than just, I would say, than just for, like for coding blocks, right? I mean, you just mentioned that, for example, it helps in terms of dependencies between the teams to know, for example, that the asset of one team is ready. And then, so I guess just before diving into the technical details, can you tell me more why first did you decide to go with YAML instead of JSON, for example? Because, there is always this battle between JSON and YAML and which one we should go with. Can you tell me more about why did you go with YAML and how, from a user perspective, like what I should do as a user if I start using your abstraction?
That's a really good question. I think that it was because we were highly influenced by dbt, right? Where you have a lot of YAML things, and it's something that people know very well. And for our data engineers, we have also Kubernetes deployments that they also work with YAML. So it was like a reasonable choice to go there. And the solution is nothing revolutionary, I think. In this case, what we thought at the beginning is like simple, it's good. Like it should be boring. It shouldn't be something very fancy.
Okay.
Because what people actually need to do is to connect different nodes in a massive graph of the whole organization, right? So what we have is that each team have their repositories, and in their repositories where they write this code that they want to orchestrate, they will have one file that it's our scheduler file. Also, the name is very boring. We had a discussion about the name, and we said like, yeah, let's put scheduler. It's that.
It's good. It's good we're not in sales, I think.
You're right. That's right. I agree.
So there you have general alerting and ownership settings, in which channel we should alert, who should we tag, etc. And do you use DBT or not? That's like, simple question, Boolean question. If you use DBT, of course, we expand the graph that DBT generates, like Cosmos, but with our little tricks. And then for other tasks, like the one that Oscar mentioned, for example, Vertex AI things, we have a declarative list of tasks. So you just make a list of what you want to do, and we connect those tasks with each other and with DBT by conditions. So what are you waiting for? And then we connect things downstream with assets. So if your task produces something that someone else will be able to use, we just put it there as, okay, this task generates A, B, and C. And the idea is that when we deploy this code generation, we not only deploy Airflow Python code, we also write to what we call our asset registry that specifies each DAG what building blocks for other teams. And in this case, I'm saying building blocks as data assets, so tables or data they are generating, and when they promise that that data will be ready. So an SLO for the people. And then, as Oscar said, these allow us to generate this abstract graph. So it's a DAG in the sense of the graph theory, and then we translate it to Airflow DAGs and to actual code. And we did this also because we want to keep the different layers independent from each other, and to be able to translate this massive graph in different ways if the time comes and we want to do something different, or we need to do an upgrade or whatever.
Okay. This is super interesting. So I guess, like, just to summarize and let me know if I'm wrong at any point. So as a user, what I'm gonna do is I have, like, I'm not gonna write any Python code. So okay, let's take a very simple example. I have a DAG with one task. Okay, one task, and I want to use, let's say, the Python operator. Then in that case, I'm not gonna write any Python code. I will have like a YAML file, like a configuration file in sense, and then I have like some fields that I will know I can use in that YAML file to describe what my pipeline is gonna do. And so, for example, this task, like the task that uses the Python operator, it will be like, I will mention the type of the task that I want and what it produces. And is that correct?
Yes,
Okay.
exactly. You have like a kind of task.
Okay.
So, for example, Kubernetes task.
Okay.
And then you specify an image, you specify a CMD command, and etc. And then the powerful thing is that you can later connect this simple YAML configuration by just declaring, okay, I need global customers data.
Okay.
Then your task will know where to look for that data in some other place, for example, right? In some other DAG. And that's connected through what we call the asset registry.
Okay. So this is thanks to the asset registry. Okay.
Yeah.
And so I guess, like, when I describe the task, how, like, I need to then I need to configure, what this task produces as an asset. Is that correct? Like, okay, yes. And that's how that's how you make the links, and that's where you register the assets in your asset registry. Okay.
I think what's interesting here as well is what we do, like Rodrigo also mentioned with these DBT settings, that we first, the Boolean question we answer is whether people are making use of DBT.
Mm-hmm.
And when they do, then we sort of dive into the lineage created by DBT, and through this way of setting up the configuration, people can actually insert in their lineage these specific tasks. So we don't have a list of tasks that will run one after the other. We go top to bottom. We actually have this setup where we have to say, what are you waiting for? And this could be different assets outside of the team is something that they could be waiting for, or a specific model deep within their DBT project. So they have a lot of flexibility in inserting these tasks in the correct spot at their lineage.
And so I guess, like, if we focus a little bit more on the assets part, if I have my DAG and it needs to wait for an asset that comes from another DAG using your solution, I guess you rely a lot on sensors, no, to make sure that the dependencies are met. Can you tell me more about that? Like, how do you coordinate the different tasks together using sensors and so on? I imagine it's pretty complex solution.
It's complex, but not complicated. Yeah, the idea is that we don't hack Airflow in any way. We are not forking Airflow and making our own things. We're using Airflow custom behaviors, so things that are already available in the tool. I'm gonna also add something to your question. It's like, why are you not using datasets or in Airflow 3 the new assets, right?
Yeah.
And the limitation that we found there is that those are very useful if you are waiting between DAGs, but we have very, very big DAGs where the dependencies can also be in different parts of the DAGs, in different tasks. And if you look at it from the DAG perspective, there might be some circular dependencies between teams.
Okay.
But inside, if you look at the tasks, there are no circular dependencies. Of course, if we wanted to use events or the datasets or the assets, we could split these bigger DAGs into smaller DAGs, but then that split, in our case, look very artificial, and people should like look into 3 or 4 DAGs to understand how they're connected and like all those things. So then what we wanted to do is the same that datasets or assets do, but with tasks. And of course, the clear candidate for that are sensors. That's quite straightforward to do. And for the sensors, you need to define a DAG where a task is running and a timeout, and we get that from the asset registry.
Okay.
But I think that the magic comes from something that we do in the tasks that are being sensed, that are the tasks that other DAGs are waiting for. That is that we have a callback function that automatically clears the sensors that are waiting for that task.
Okay.
If everything goes well, you don't need that because everything goes well, the sensor works, and yeah, you're happy. But if one team has something that fails and your sensor fails in another part, then when you fix your thing, you need to tell the other person, like, hey, I fixed my thing, can you rerun? And then you need to start this communication in this decentralized way that it's very annoying. If you have like 15 people saying like, hey, are you done? Have you fixed it? Whatever. So then what we have here is that with that callback function, when you fix your things, if someone else is waiting for that and the sensor is still in their timeout, you don't even know. But when the sensor failed and you know that someone is in fault, when you fix it, you automatically retrigger everything. So in this way, we are connecting all the DAGs as if they were one massive one, but in little blocks.
Okay.
And this is also quite cool because of the alerting that we can do with that. Because the owner of the task can know that their thing failed, but then the sensor person can know like, hey, something failed in your pipeline, but it's this other person's fault or responsibility, let's say.
I see.
So you can go find them, you can help them to fix the problem, and then when they fix their
Lady system.
everything resumes automatically and everything it's cleared up. And yeah, in a sense, it works as the datasets or assets, but at the task level.
Okay.
And I think that's the powerful thing of it.
I love the solution because, in a way, it seems that you definitely had some constraints in terms of how you can create your pipelines, but also, based on your explanations, it feels also that you add some flexibility in terms of how, the fact that you go at the task level for, creating the dependencies and so on, like it actually adds some flexibility as well, which is fine, which is truly, honestly, that's the first time that I hear that. So can you, speaking of constraints, obviously, like, I'm sure that the solution is great, but you know what it is, right? Like, for some engineers, they don't like that much the constraints. For example, let's say I want to add a task that it is not in the provided list that you have, of tasks that I can use. Like, how does it work then? If I want to add something that it is not in the system yet, how does it work? Should I raise a ticket? I don't know.
Be all great. We can be all great. Huh? So it's a good question and definitely a relatable one. The way we try to mitigate it is through that possibility to create a container. So a team can create a container with their custom solution or custom code that they can then schedule. So we have a full CI/CD system that then can create this container. It ends up in the correct registry, and then they can configure this as a task block through the kind Kubernetes in order to ensure that this is still feasible. So in practice, we have this solution, but we definitely find people still feel constrained. I think one of the difficulties that this sensor setup introduces is that we have to set specific fixed schedules. So we cannot say that everyone is free to set up their cron, because then through the behavior of a sensor, it would be very difficult to know which interval to pull, because it's like Rodrigo said, it's one connected tag, but we still want to connect it on the right intervals. We can't just say pick any, and if you find a green block somewhere, go ahead. Actually, that might be a cool feature.
Yeah, actually, yeah, that sounds great. Actually, that sounds a good feature. But okay.
Yeah. So, with that in mind, we had one of the constraints set up to be you can only select a predefined set of schedules, say daily, hourly, weekly. And users at first, there was a bit of backlash, but luckily we had one of the soldiers in our team, so he could keep everyone at bay. But it also sort of introduced a new way of thinking from us. So do you really need this every once in a blue moon when it's the year of the dragon kind of cron setup? Or can you remodel your solution to be fitting to an hourly pipeline so that whatever your solution produces can also be used according to specific expectations and rules by other teams without needing to set up 17 meetings to understand how to connect the two together? So in terms of falling back to your question, these constraints, depending on the persona you are dealing with, it can be taken in different ways, but we see them as a very positive thing.
And
interesting this.
Yeah, and I'm sure. I mean, obviously, actually, I can relate a lot on what you said about do you truly need that? Because it's always easy to add things, but it's much harder to remove those things. So it's nice to think twice about, okay, do I truly need that? And if so, then let's figure out the right way to do it, to add that. But you just mentioned, we mentioned constraints, but I'm sure that when we have this layer of abstraction, it can help a lot in terms of migration. Like whenever you need to upgrade Airflow, for example, like can you tell me more about that? Like, actually, does that solution help in terms of migrating your DAGs or migrating from Airflow 2.10 to 3, for example? Like, something that you find that?
This helps massively.
Okay.
So we used to have periodical upgrades, I think back in the time of 2.6 to 2.7, and so on, where we didn't have this generator, or we didn't have this centralized solution of a limited amount of building blocks.
Right.
And what we found in setups is that people are creating their own solutions, and they might have different dependencies, and some might be better maintainers than others. And then you have to put them all in one bag, and then from one day to the other say, okay, we're going to run this upgrade. And you have to sift through, I mean, Python is notorious for this, all the dependency issues you might have for any breaking change that might be introduced along the way. So we had to go team by team to understand, okay, can we change this? We don't know where it's used, downstream or upstream. Things weren't connected properly. So we were interviewing all of the time. And then there was a big script of steps to follow for running such a migration. I think a lot of platforms with data engineers will be familiar with this this problem. I don't think it will be new to many people. But in the case of this generator, what we do through this abstraction is that we force people to create their pipelines based on a limited amount of building blocks.
Right.
I think the one we would use the majority of is this GKE pod operator, where people run containers. And imagine so you start out where you have hundreds of operators, you have to have hundreds of cases that you have to fix. And then you boil it down to, we are running 2 or 3 operators.
Right.
Now we have to go through those operators, fix the breaking changes, if any. And the best part is we know how they connect to one another, right? We know through the sensor setup how things are orchestrated, how things are connected. So we don't have to go around and ask this question anymore. So it's a massive win in terms of maintenance and the ability to upgrade, but also I would even extend it to how we scale the system. If you have the exact expectation of what's going to be running or what kind of tasks are going to be running, you can really design your solution around that. And we don't have to account for people introducing unexpected building blocks that might be very resource intensive or hungry. And we have to change our system to fit those needs. So yeah, for us, it's a massive win in that sense. And with the generator setup, we provide the flexibility that our users need. So I say win all across the board.
Yeah, and I think also the advantage is that you are decoupling what the users do,
right,
from what the platform is doing. So then you can change the platform all you want. You only need to keep the interface working, and that's easy because we control the interface, right? So then, yeah, people don't need to change anything or almost anything, and we can, just change that connection and make it work, and that's very powerful. And I think people is very happy with that because they cannot believe, like, okay, I only need to put DBT truth and it works.
We have happy users as well, believe
We
it or
have
not.
happy people because you also give time back to them to focusing in what is their area of expertise, right? Like, why are they don't want to debug Airflow problems because they are not expert in Airflow. They want to debug Vertex AI problems. So, okay, you just don't need to debug them anymore. So they're quite happy with that, I think.
Yeah, that's what I was about to say. Obviously, as you said, right? Like if I'm a data engineer, if I'm a data analyst, if I'm a ML engineer, whatever, like I have different expertise. I have a different expertise, and maybe I don't want to spend a ton of time on debugging Airflow and so on. I actually want to focus on things that matter a lot, and your solution seems to do that. And also, like as a data engineer, but I'm sure that it is the case for other engineers as well. But I don't like being stuck in Airflow 2 just because I have so many customizations, so many things that I built on top of Airflow. So actually your solution provides also a great way to migrate from different Airflow versions, without having to go through a ton of fixes just because, again, too many things built on top of Airflow right away. So yeah, I'm sure that definitely like people love your solution at your company. I'm sure they do. I guess like one very last technical question. Do you rely a lot on, container operators like the Kubernetes pod operator? Is it something that you actually rely a lot on, or do you use the classic Python operator or something like that?
Basically, all we use are the container operators. So we are connecting to Kubernetes and we run everything in the containers. I think it's also Fallen makes an interesting question because for me, the power of Airflow is especially very strong when you get started, because there's such a huge open source community. The chances of there already having been someone that created an operator that may fit to your platform or your use case is incredibly big. So I think getting started is a massive win, and you can really set up your pipelines from scratch in a quick manner.
Mhm.
However, when you scale to a larger company, I think this strong suit of Airflow can turn into a challenge because of the reasons mentioned. Maintaining a system where teams start grabbing operators out of the thin air, out of the abundance of operators that are there. The only one I would still allow is the smooth operator.
Yeah, of course.
For listeners that are not familiar with this one, look it up. It's amazing. Put it in your pipelines. Have a laugh.
Basically it brings AGI in your pipeline.
Exactly. Bring a bit of flair to your pipelines. It's important. We have to enjoy our work, right?
I agree. That's amazing. I mean, look, guys, I could spend like hours with you. It's truly amazing. But I just would like to mention one last thing. This is just for the audience, actually, for the listeners. This is just a taste of Oscar and Rodrigo solution that they have implemented in their company. If you want to learn more about that, you will learn more about that in the Airflow Summit. So again, like I think that's a really solid solution. I can't wait to be at the Airflow Summit as well to learn more about the implementation of it. But can you tell to the audience what is the best way for folks actually to get in touch with you? You know, if they would like to learn more about your solution, if they want to just speak with you and so on.
Yeah, definitely. I think the best way, at least for me, it will be to look it up in LinkedIn. I'm there. I have an abandoned Substack that I write some stuff once in a while when I want to rant about something. But yeah, LinkedIn definitely.
Okay.
You can
There it goes for me. Just type the name in LinkedIn and feel free to connect, and I'll happily have a discussion and dive a bit deeper into the solution or be criticized even. Also
Awesome. Well, guys, again, thank you so much for joining. It was a wonderful pleasure. And I mean, who knows? Maybe I will see you again for another episode. But thank you so much.
we love that. Thank you so much.